Okay, guys, so new chapter. Technically, the last chapter in the book, but we're still going to come back around and do chapter 8 here at the end. So, chapter 10 is building on what we learned in chapter 9 about area and composite shapes. So, follow along with me. I'm on page 410 of your book. We're doing 10.1. Okay, so the first thing I want you to write down is this vocab. So we have been talking about area. And remember, I'll just do a quick little reminder for you. Area is the space inside of your shape, right? So let's just say I had a square. Well, let's make it a rectangle because again, I struggle with drawing a perfect square. And I had my length and I had my width. And my area would be how much space fills up that rectangle, right? So area equals length times width. Simple. And we remembered that it was different for circles and triangles as well. But what happens if I have a three-dimensional shape? What if I had one of our Rubik's Cubes? And I said, what's the area of that? Well, you could easily find the area of one side, but what's the area of all the sides? That's what surface area is, right? And so if I had one of our Rubik's Cubes and I wanted to know what is the area of all the faces, the surface of it, that is called our surface area. To find out the actual amount of space inside of the Rubik's Cube, that's called volume. We'll get there later. So let's focus on this surface area idea. What's the area of the surface of the shape? How you're going to do that is just find the area of all the different sides and then add them up, right? So this is saying find the area of the bases, so that's your top and your bottom, and then find the area of your lateral faces. So these are the sides, and this is your top and bottom. All right? So this is the surface area, okay? So we're gonna do a couple examples of these. We're gonna start with some prisms. Prisms just mean that there are two bases, a base at the top and the base at the bottom, like a Rubik's Cube, but you can also have like triangular prisms. We'll look at some of those too. Now, before we get to solving any problems, I want to kind of use this visual here. You have this in your textbook to kind of explain to you the vocab term and the formula I just said. So your surface area, again, is the area of all the sides. So if you look at this rectangular prism here, this is not a rectangle, it's a prism, it's three-dimensional. You can see that they want to find out what's the space on the surface. They're not worried about like how much empty space is inside the box. They just want to know what is the area of each side. So we're going to find the area of our bases, which would be the top here, and there's another one under there we can't really see. So you can just imagine it being unfolded. That's what this is. This is just them imagining if you unfolded the whole box, right? So you have your two bases. So you're going to figure out what those are. So an easy way to do it is figure out the area of that base, length times width, and then multiply it by 2 because there's 2. That's what this is. 2 times length times width, right? Now I'm going to change the color for us. Now, the next part was find the area of the lateral faces. If all the faces were the same size, you could just do 4 times that, but you can look at this and see that, well, these two guys right here are the same size. The other two are the same size. So let's figure out the area of this. So that's length times width times 2 again, right? And then the last two, these guys here are the same. So we can do length times width, right? And then multiply that by 2 as well. So then you would get all those and add them up, and that would be your surface area. Okay, so now let's try one. We have a rectangular prism here, and the same thing, we're going to figure out the area of our bases first. We have a base at the top here, the little red one, and you can imagine there's one at the bottom too. You can't see it, but you can see the dotted line that shows you that it's also 3 by 5. So it's the same, we can just multiply that by 2. So for the base, 2 times 3 times 5, because remember, area is just length times width, so 3 times 5. So that's the area of our bases, plus the area of our sides. Now look at this. Are all our sides the same? They're not, because this one is 5 inches across and this one's 3. If they were all the same, like a cube, you could just multiply by 4. Since they're different, we have to do those sides separately. So let's start by doing these faces here. And there's a matching one in the back. So that's going to be 2 times 3 times 6, because again, area, base times height. And then the last one is this face here and the mirror one on the other side. So that's 2 times 5 times, what's the height? It's still 6. All right, so then we just have to put it all together. That would give us 30 plus 36 plus 60. Final answer, 126 inches squared, because remember, area is, you put the square on your units, right? So that is how we find the surface area of a prism. Now I'm going to let you try some. All right, so now I want you to pause, try to find the surface area of these 2 rectangular prisms, and then come back here and check your answers, and I'll kind of walk you through these as well. Okay, so for your answers, you should have had 52 feet squared and 288 meters squared. So I'll walk you through the first one just so we have one more example to look at, and then we'll move on. So again, our bases, what's the area of our bases? We have a base up here and a matching one at the bottom, and we know that it's 2 by 3. So 2 times, because there's 2 of them, times 2 times 3, right? Plus, let's do our sides. Let's start with these ones. There's 2 of them, times 2 times 4. And then last sides, we have 2 of them, and that is 3 times 4. So 2 times 3 is 6, times 2 is 12. 2 times 2 is 4, times 4 is 16. And 2 times 3 is 6, times 4 is 24. All right, and then you are going to add all those up, and you would end up with 52. And remember, it's area, so it's feet squared. All right, and you would have done the same thing for the next one. So now let's look at a different type of prism, and we're going to use the same formula though. Okay, so now we have a different type of prism. This is a triangular prism because if you look at the base, it's a triangle. These 2 pictures are the exact same shape. It's just like from our first example, they showed you what it would be like if it was unfolded. So when you're looking at these, you kind of have to imagine what they look like unfolded. But this is like over here what you would get from the problem. So same thing though. We're going to figure out what is the area of our bases. In case you forgot, area of a triangle equals 1/2 times base times height. All right, so let's figure out now what is the area of our bases. So we still have 2 of them, so we know it's going to be 2 times, well, 2 times 1/2 times, what's our base? Our base is 3. And our height right here is 4. Now I know you might have seen the 5 up here. That's not our height, that's the slant. Remember when you're trying to figure out the base and the height, imagine that you have it sitting straight up, right? So if we were to sit it straight up and 3 was the base, 4 would be the height, not the 5. All right, so that's the area of our bases. We're gonna add that to the sides. Again, our sides are not the exact same. So we're going to try to figure out what they are. On this one, we actually have 3 completely different sides. So none of them are going to be multiplied by 2. So first let's figure out, well, what is the area of that first side? Let's look at the green one. And over here, they were nice enough to like imagine it out for you, but I'm gonna just focus on this one because you're not gonna have it flat like that on your homework questions. So area of that one, it's a rectangle, base times height, that's 3 times 6, if you look at the height. So 3 times 6, that's 18. There we go. Then let's look at the blue one over here because we can still see that one. That's 4 times 6, so that's 24. And the last one, we can't really see it back there, but we can figure out what it is. They drew it and made it purple for us, but if you imagine, you can see right here, it goes across 5, and it's 6 meters high. So that's 5 times 6, so it's 30, all right? So then we add all those up. This right here equals 6. So that ends up being 6 times 2, so 12 plus 18 plus 24 plus 30 equals 84 meters, and it's still area, so squared. All right, so that's how you would do a triangular prism. I'm going to give you one to try, and then I'm going to come back and go over the solution with you. Okay, so pause, find the solution to this one. This is another triangular prism. Then come back and check your answer, and I'm going to go over it with you. Okay, so the answer that you should have gotten for this one would be 150 meters squared. And I'm going to show you how we got that. So we're going to start by finding, again, area of our bases. So that's up here, and there's a mirror one at the bottom. All right, so what's the area of a triangle? 1/2 times base times height. All right, so area of that triangle would be 5 times 12 times 1/2, which would give us 30, because 5 times 12 is 60, divided by 2 is 30. So 30, and we have 2 of them. So 2 times 30, that's our bases. Now we need to figure out our faces. There's a face right here that is 13 by 3. So area of that is just a rectangle. So that's just going to be 13 times 3. Now on the base on the opposite side, you might jump and think, oh, that's the same size. It's not. You see how there's a 12 there. So that is 12 by 3. And then our last side is this little rectangle there. And even though it kind of looks like a square, remember the height is 3. So it's a rectangle. It's 5 by 3. So now let's figure out what all these numbers are and put it together. 30 and 2 is 60. 13 and 3 is 39, right? 12 and 3 is 36. And then 5 and 3 is 15. Add all that up, you should get 150. Unit is meters and it's area, so it's squared. All right, and that is lesson 10.1, all surface area of a prism. Hopefully you were taking your notes as we go. Good luck.